In this video, we derive our final 4 formulas for antiderivatives, antiderivatives of trig functions, using antidifferentiation by substitution. So I'll start with these two. We don't have rules for this yet, but we can find the antiderivative of this function now that we know how to do a u-substitution. Tangent, we all know, can be rewritten as sine of x over cosine of x. Now, we do have a rule for this on our sheet, but if you want to know where that rule comes from, it comes from u-substitution. So I write tangent of x this way. I see I've got a quotient. There are no quotient rules for antiderivatives, but I can use a u-substitution to evaluate this antiderivative. So in order to do that, I need to identify a u. Now, a lot of students get confused with this part because they think, well, the derivative of sine is cosine and the derivative of cosine is sine, so don't I have two options for u? It looks like that on the surface, but you really don't. We need du, that function of x times dx, as an extra factor. We can't have a du with part of that du in the denominator. So if I let u equal sine of x, du is cosine of x dx. And I don't actually have cosine of x dx, I have a 1 over cosine of x dx. So u can't be sine, u has to be the denominator, u has to be cosine. So we let u equal cosine of x, then the derivative of cosine is negative sine of x. So du is negative sine of x dx. And then we substitute, we replace every single part of this with something in terms of u. We don't want any x's, we only want u's. Well, since there's no negative up here, I can multiply both sides of that equation by -1. Negative du is sine of x dx. So I replace sine of x dx with a -1 times du. That's negative du. And then this is a u in the denominator. So that's not the negative integral of u du. That's the negative integral of 1 over u du. Because that u is not, that cosine is not in the numerator, it's in the denominator. And then I just antidifferentiate this. The antiderivative of 1 over u is natural log of the absolute value of u plus c. And then we back substitute. U was cosine of x. So if you choose, you can memorize this. You can say the antiderivative of tangent of x is negative natural log of the absolute value of cosine of x plus c. You can just memorize that if you want to, or you can remember where it comes from. I prefer that you remember where it comes from. Tangent of x is sine of x over cosine of x, and that's easy to integrate. All I have to do is rewrite it in terms of sine and cosine and let u be my denominator, and then I get this answer. So this is one more rule for your note cards. I recommend that you be very familiar with this rule. Antiderivative of tangent is negative cosine of x, or negative natural log of the absolute value of cosine of x, excuse me, plus c. That's one rule on your sheet. That's where that comes from. But sometimes this one is written in another way as well. Remember this rule from algebra? If you've got a constant in front of a logarithm, you can bring that constant inside and make it a power. That's true here. So there's a -1, there's an extra -1 factor there. So we could write this as natural log of the absolute value of cosine of x raised to the -1 plus c, but 1 over cosine is actually secant. So sometimes you'll see this rule written this way. The antiderivative of tangent of x is natural log of the absolute value of secant of x plus c. Either one of those is fine. Those are both the same thing because of this identity right here and because of the fact that 1 over cosine of x is secant of x by definition. Okay, so there's your rule for tangent. You can do exactly the same thing for cotangent. Cotangent, remember, is cosine of x over sine of x. I let u be my denominator. Derivative of sine of x is cosine of x, so du is cosine of x dx. So I've got a u down here and a du up there. So this is the integral of 1 over u, and cosine of x dx is du. The antiderivative of 1 over u we know is natural log of the absolute value of u plus c. And then you back substitute. U was sine. So now we've got a new rule. The antiderivative of cotangent of x is natural log of the absolute value of sine of x plus c. I highly recommend you guys add these to your note cards, but always remember where they come from. Tangent and cotangent can be easily found. If you forget the identity, you can find it easily by writing tangent as sine over cosine, or writing cotangent as cosine over sine, and then doing a u sub where u is the denominator. U is never the numerator, because that cosine of x isn't really a cosine of x factor. It's a 1 over cosine of x factor, so the du wouldn't be up there. Okay, the next two antiderivative formulas for trig functions that we're going to derive using u-substitution are a little bit less obvious. So we've got two more. And this is for secant of x. Now, this is cool. This is probably not something any one of us would have thought of. It's not something I probably would have thought of. But watch what happens. I've got secant of x, so I'm trying to find the antiderivative of secant of x, and someone said, hey, why don't you multiply that by secant of x plus tangent of x over secant of x plus tangent of x? I'm like, okay, I can do that. So I'll write that as a fraction and we'll multiply straight across. I have secant of x times secant plus tangent. Secant times secant is secant squared. And then I've got secant times tangent right there. That's in my numerator. All of that is over secant of x plus tangent of x. A lot of students try to factor out a secant and then they just go back to right where they came from. You don't want to factor out a secant here. We multiplied by this so that we could use a u sub to evaluate this integral. If you're saying, what should my u be? Well, if there are no parentheses, do what I always suggest. Try the denominator. It often works, and this time it does. If u equals secant of x plus tangent of x, du is just the derivative of that times dx. Well, the derivative of secant of x is secant of x tangent of x, and the derivative of tangent of x is secant squared x. So I end up with this times dx. That's exactly what we have in our numerator. So this becomes another 1 over u, because my u is in the denominator, times du. And we know the antiderivative of 1 over u is natural log of the absolute value of u plus c. And then we evaluate this at secant of x plus tangent of x. So we replace u with secant x plus tangent x. Then we add c. And that's it. Oh, I forgot to put the rest of the rule up there. This is your new rule. The antiderivative of secant is natural log of secant plus tangent. Don't forget the absolute value. And that's great. It just comes from multiplying by this extra factor. If we multiply by this, which is just multiplying by 1, it doesn't change anything, then we end up right here. And this can be found with a u-substitution, because it just so happens that the derivative of secant plus tangent is secant plus tangent times an extra secant. Since that works out, then the antiderivative of this must be this. So we had tangent and cotangent, they were very similar. And we have secant, looks like this. The other one, the one rule that we haven't talked about, is cosecant. And as you can imagine, it's very similar to this. Excuse me. So I want to derive a rule for cosecant of x. I don't have one, but I know how to do u-substitution now. So now what we're going to do is we're going to take our cosecant of x integrand, and we're going to multiply it by cosecant of x plus cotangent of x divided by itself. Again, that's just multiplying by 1. Now, if I write that as a fraction, and I multiply straight across, so I distribute that cosecant of x to here and there, we get this. Cosecant times cosecant is cosecant squared x. Cosecant times cotangent. I'm starting to recognize that. Derivative of there's a function that we can take the derivative of where we get cosecant squared. It's negative cotangent. And there's a function we can take the derivative of to get this. It's negative cosecant. And guess what we have in our denominator? We have cosecant plus cotangent. So this can be solved with a u-substitution as well. We let u be the denominator. And then we compute du. Now the derivative of cosecant of x is negative cosecant of x cotangent of x. And the derivative of cotangent of x is negative cosecant squared x. We take all of that and we multiply by dx. Now, these have a negative factor and this doesn't. So we have to factor out the negative. And then since I'm trying to get all of this by itself, but without that negative sign, I'll multiply both sides by -1. And this piece turns out to be -1 times du. And that u is just a u in the denominator. Don't forget that it's in the denominator. So we have a 1 over u and a -1 times du. So I've got a -1 times the antiderivative of 1 over u with respect to u. And we know what that is. That's negative natural log of the absolute value of u plus c. And then we replace u with whatever u was in terms of x. So that gets replaced with a cosecant of x plus cotangent of x plus c. So you can memorize this if you want to, or you can remember where it comes from, which is what I'd prefer. But I would put this on your note cards. You want to remember this as one of your basic rules. Notice the similarity between this one and the rule for secant that we just looked at. The antiderivative of secant is natural log of the absolute value of secant plus tangent. The antiderivative of cosecant is negative natural log of the absolute value of cosecant plus cotangent. It looks the same, it's very similar. Just replace all the secants with cosecants, replace the tangents with cotangents, and the identity that involves the co-functions gets a negative. And that's very common. Now tangent and cotangent are a little different, but tangent is the negative natural log of the absolute value of cosine. Cotangent is the positive natural log of the absolute value of sine. But those two are very similar and they're derived in the same way. You just write tangent and cotangent in terms of sine and cosine and do a u-sub. So now we've got 4 new rules. Those were those rules at the bottom of your sheet. So now we've got all 10 of these rules for our antiderivatives of trig functions. The first 6 were those derivative rules in reverse, And now because of u-sub, we've got 4 more. So we can take the antiderivative of tangent now, cotangent, secant, and cosecant. We were already able to take the antiderivative of sine and cosine. And then because the derivative of tangent, secant, cotangent, and cosecant those derivatives were secant squared, secant tangent, negative cosecant squared, negative cosecant cotangent, we were able to do those backwards as well. So we've got all these. We're good to go. We have these. In the next video, I'm going to introduce these and talk about how we can solve related integrals with u-substitution and completing the square. And then we'll be done with all of our integration rules. So just one more video for integration rules.